It's amazing how many superworlds the new James Webb Space Telescope has already detected, thanks to extremely accurate spectrometer analyses. The time is drawing near for NASA to finally declare that a planet has been discovered that exactly resembles Earth and even supports life in theory. The NASA telescope has struck again, finding another planet that is even better suited for life than our Earth. By carefully examining the spectrometer of a planet outside of our solar system, the James Webb Space Telescope, or JWST for short, can find signs of life on far-off planets. From this analysis, scientists and space enthusiasts can determine the amount of water present in a planet's environment, the composition of its atmosphere, and its surface temperature. From this information, researchers can find the first biomarkers that point to the existence of life. The James Webb Space Telescope has already made some groundbreaking discoveries. Planets that resemble Earth so much or that contain so much water might be even more suitable for life than our own. The most amazing IC telescope ever created, the JWST, has the potential to detect artificial light on a planet. It does this by using the MORE spectrometer, which is so finely tuned that it can easily distinguish artificial light waves from natural ones. This puts us closer than ever to finding a second Earth and possibly other forms of life. Scientists refer to these ideal habitable worlds as super-Earths. Imagine being able to see thousands of light-years with a telescope positioned in Earth's orbit and obtain precise exoplanet analyses. Humans have only been able to detect other planets in the cosmos since the mid-1990s. But the problem with these far-off planets is that they are small and do not emit light of their own, making them difficult to detect in the dark expanses of the universe. For this reason, JWST has been specially equipped with infrared technology, which for the first time makes it possible to capture even the tiniest light traces from the universe. You may wonder how that is supposed to aid in the detection of exoplanets when they don't emit any light themselves. That's exactly right. But researchers employ a trick in which light does not play a role. Transit observation is another method for finding exoplanets. When a planet passes in front of its star, it causes a slight dimming, which the JWST can easily detect with its keen eyes. This method is unique and has cost its builders a fortune. The important role of stars is that they are tiny even at great distances, and exoplanets often appear no larger than a grain of dust. Despite their small size, they are obviously heavy weights that exert gravitational effects in distant star systems, and this is exactly what its spectrometers can measure. The new Earth, K2-18b, is a hot candidate for an Earth 2. With its enormous, honeycomb-shaped observation mirrors, this telescope can see farther and in more detail than any other before it. What exactly has the JWST discovered that has scientists so excited? K2-18b is an exoplanet about 2.7 times the size of Earth and about 8 times its mass. The JWST detected it about 124 light-years away there. The planet orbits a red dwarf star in the habitable zone, meaning that it is at the ideal distance from its star to support life. Additionally, the JWST has found obvious signs of water in the atmosphere of K2-18b, which has further piqued scientists' interest. Water is an important indicator for life, as we know. Water worlds have long been considered rare in astronomy, but now, more and more, distant worlds are emerging where we can be sure that they have a water-bearing atmosphere and probably also harbor larger water deposits on the surface. K2-18b is located in the so-called Goldilocks zone, which means that liquid water is almost certainly present there. If this is the case, there is a very high probability that the planet also has some form of life. Scientists are painting a picture of a super-R that is possibly a blue-green wonderland similar to our own. A planet almost 3 times the size of Earth could harbor even more life and have landscapes and features that are difficult for us to imagine. The exciting question of, course is how we would definitely prove the existence of life on K2-18b, although MIRI found no evidence of artificial life, which would be a clear indication of higher life. We still don't know whether other species use light sources similar to ours, or whether other peoples may have developed completely different lighting techniques in our search for other life forms in space. We must not forget that only microorganisms, simple life forms such as fish or snails, or creatures like dinosaurs or other fantastic beings, can live on a planet they would not produce any artificial light, and yet life would still be there. Researchers are now developing a method to use the Webb Telescope's fine spectrometer in order to potentially find evidence of metabolic activity on exoplanets. This could include identifying specific gases that show how land creatures breathe, or figuring out whether bacteria and oceans affect the atmosphere. Planets of Tatooine with 2 suns. Who hasn't heard of Tatooine, the well-known planet from Star Wars with 2 suns? It turns out that 2 suns are more common than we might think. In fact, binary systems are fairly common in space, and we even know of systems with 3 to 6 stars. While it would be strange and incredibly fascinating to imagine a world illuminated by 6 suns, scientists have discovered a class of exoplanets that are obviously gaseous and roughly the size of Jupiter. These exoplanets always orbit 2 stars, and some of them are so close to their stars that they are extremely hot, with temperatures that most likely make life as we know it impossible. However, because academics are paying special attention to these Tatooine worlds, we may discover something that we are unaware of yet. Space continually demonstrates that when it comes to exploring other worlds, people nevertheless frequently have a very limited focus. Directly across from Proxima Centauri b is Earth 2. Did you know that a privately funded project called Starshot Breakthrough is currently building a nanoship that will be the first artificial probes to fly to a distant star system? The project plans to send an armada of tiny probes to the Proxima Centauri system 4.24 light-years away in a few years. A few years ago, the exoplanet Proxima Centauri b attracted attention there. It was clearly identified as a rocky planet and showed ever more astonishing similarities to our Earth. A second Earth just around the galactic corner would have been spectacular, but after the initial excitement subsided, new measurements revealed that the planet, which is slightly larger than Earth, orbits its star so closely that it probably cannot be a new Earth given how close Proxima Centauri b is to the red dwarf. Because red dwarfs emit far less light than our Sun, Proxima Centauri was initially not a threat to life. However, in the case of Proxima Centauri b, researchers noticed that the red dwarf star sent violent flares in the direction of the planet for a while. The star's ejections were so strong that the radiation on the planet's surface made life impossible. Despite this, the Starshot project still believes that life could exist there, or at the very least that this planet is so intriguing that we should investigate it further. The Proxima system is believed to contain additional planets that would be worthwhile to investigate. In addition, humans must develop technologies that will allow us to conduct more thorough exploration of exoplanets. Researchers plan to use a unique technology to accelerate the spaceships to nearly the speed of light, which would allow the mini probes to examine an alien star system for the first time after just over 4 years of flight. The spaceships will only be a few centimeters in size and will be outfitted with numerous cameras and other crucial sensors. Although Ross 128b is only marginally larger than Earth and orbits a red dwarf star, observations revealed that the star is significantly calmer than Proxima b. If the plan for Starshot Breakthrough succeeds, we could also send probes to this planet, which is 11 light-years away and nearly identical to Earth. Because of this, Ross 128b is probably going to get a lot less radiation and is in the habitable zone. Scientists are currently awaiting the James Webb Telescope to offer the first accurate observational data on this planet. Only a small percentage of the more than 5,000 exoplanets that we presently know about resemble Earth. There are many different kinds of planets in the universe. Some of them are similar to our planets in the solar system, while others are strange and unusual. For example, in our search for life in space, we naturally concentrate on rocky planets, which are typically much smaller and therefore more difficult to detect. However, we have a list of nearly 30 planets that may be very similar to Earth. Only then will the Webb telescope be able to gradually go through this list and give us detailed spectrometer analyses of all these worlds. Only then will we be able to determine with certainty where there is water and where we need to search further if we eventually want to find other life forms in the universe. Subscribe now to ensure you never miss another video.